There's three areas I'd like to talk about, though, in a bit more detail this evening that Intergovernmental Panel on Climate Change didn't really cover very well for a number of reasons. The first reason is that they stopped collecting their data in 2005, and we've had a couple of years of really interesting scientific discoveries since then. The second is that they backed away from areas of great uncertainty, and our climate system is full of what are called non-linearities. It's where there are sudden shifts. And they're very difficult to model. If you look at any of the computer projections, you'll see they're all just linear. So these non-linear changes are difficult to model, and the IPCC explained in footnotes and other things that they weren't dealing with these problems, but many of us miss those footnotes. The first of the big changes I want to cover concerns the extent of the Arctic ice cap across the north of our planet. As you all know, there's an ocean across the North Pole, and there's an ice cap on top of that with ice several feet thick. Since the mid-1970s, that ice cap has been melting away at the rate of about 8% per decade. And so we knew in 2005 that by 2100 there would be no more ice cap, because that rate, you just continue the line down till it intersects with the timeline, and it happens about 2100. And that's what I wrote in that book. But over the summer of 2005, as I was putting the finishing touches on the book, the Northern Summer, a really extraordinary phenomenon occurred across the Arctic North. The rate of melt of that ice cap accelerated 4 or 5 times. And that melted about 300,000 square kilometres. I'm sorry I can't give you that in square miles, but it's a very, very large area of ice melted. And I remember emailing my colleagues in Canada and asking, what did this mean? And they all sent back things like, oh, well, it's 1 year's worth of data. Maybe it's like the weather. You know, sometimes you get a hot day, sometimes you get a cold day. Maybe it's not all that meaningful. So I let it go, didn't think much about it. Through that winter, however, I watched the figures emerge, and it was very clear there was something wrong with the formation of the winter ice. The winter ice is what the ecosystem up there depends upon. It lives on the bottom of that ice with the algae and various small organisms in the plankton that live on the bottom of the winter ice. It was impeded, its rate of formation was impeded 10 or 15-fold. So by the next summer, as we came into the summer melt season, the ice cap was vulnerable, and a very large amount again melted. Not quite as much as 2005, but a significantly large amount of ice. This really started to ring alarm bells with some people, including myself. And a scientific publication was published just a couple of months ago, suggesting that instead of having to wait till 2100 for the polar ice to disappear, it may disappear as early as 2040. Now that ice cap's been around for several million years, probably 3 million years, and there's so many unique life forms that are adapted to that unique environment, from walrus to polar bears to many other species. And of course it plays an important role, that ice cap, in terms of regulating our entire planet. It's lovely bright ice. When the sunlight hits it, that 24 hours a day of sun, putting down 240 watts per square metre of energy onto that ice cap, it all bounces back into space, or 90% of it bounces back into space. But once the ice melts, the dark ocean underneath is revealed, and instead of 90% of that 240 watts being bounced back into space, it's absorbed by the oceans and turned into heat energy. And we think what happened in 2005 was that enough of the ice had melted to reveal enough ocean to trap significantly large amounts of heat that started melting the ice more rapidly and then impeding its formation through the following winter. Now this is still theory, still very new. We'll know this summer if it's going to continue, and if the trend continues, I think we should really ring the alarm bells. 3 years in a row is not just freakish. I think and the declines are so rapid. I should just give you a sense. If you just drew a straight line through those 2 points, not 2005, 2006, down to the timeline to work out if it kept melting at that rate where it would be, the ice cap would be gone in around 20 years. So it's quite a serious problem. And once the ice cap goes, the North Polar Ocean will warm by about 12 degrees, and that will change the Northern Hemisphere's climate. The structure of the Northern Hemisphere's climate it's regulated by the gradient between the pole and the equator. Change the pole, and you have to change the Northern Hemisphere's climate system. How that will work out, what will happen, I think is still a great unknown. But it is worrying to see that Arctic ice decline at the rate it has over the last 2 years. as I said, this summer we'll know. I really hope that we see a much slower rate of melt. It's yet to be seen. One of the consequences of melting that ice really brings me on to the second point that the IPCC didn't cover very well, which is how rapidly the oceans will rise as a result of all of the melting ice. It's pretty common sense, isn't it, that in a warmer world the ice will melt? Well, common sense is what the science says too. It's going to keep melting. There's enough ice on our planet, were it all to melt, to raise global sea levels by 80 metres. So it's that's 80 metres is what, 240 odd feet, something like that. So the seas can come up a lot if all of that were to melt. There's no way all of that ice is going to melt in this century, but significant bits of it may. And that's where the Arctic ice comes into it. Arctic ice won't raise the sea level. It's like, if you can imagine melting an ice cube in a glass of scotch, you know, it doesn't raise the level of the liquid in the glass. But land ice will raise the level of the oceans. The Greenland ice cap's the last remnant of an enormous ice cap that dominated much of the northern hemisphere just 20,000 years ago. There's enough ice in the Greenland ice cap to raise global sea levels by about 6 metres if it were all to melt. It's a very large ice cap. And as the oceans warm around Greenland, and as the atmosphere above Greenland warms, more pressure is put on that ice. And we see that result year by year. Ever more of the surface of the ice cap is melting and forming large ponds, and that water runs down through eskers or holes in the ice through to the interface of the bedrock and the ice, which is 2 miles down, and lubricates that bedrock. One way we know that that's happening is that the ice is starting to move, and the movement's betrayed by the occurrence of glacial earthquakes. They happen when a piece of ice moves very suddenly. Some of them are very large. You can have Richter scale 5 glacial earthquakes, which I'm sure you've probably felt a Richter scale 5 earthquake in this part of the world. And you know that happens in Greenland when a piece of ice the size of Greater Seattle shifts rapidly 10 metres or 20 metres or something on that order. Up to 2003, the number of glacial earthquakes that had occurred on the Greenland ice cap was less than 15 per annum. Sometimes as few as 6, but certainly less than 15. 2004, we saw 24 glacial earthquakes occur, and then 2005, 32 glacial earthquakes occur. So there's increasing instability in that ice cap. It's shedding ice at the rate of 150 cubic kilometres per year at the moment. Very large rates of melt. And I am concerned that at the moment that ice is adding to sea level rise by about 1 millimetre per year. So 1 out of the 3 millimetres we're experiencing at present per annum. But I'm concerned that that melt is acting to further destabilise other ice caps in the Antarctic. There's a very large ice sheet called the West Antarctic ice sheet, which is larger than the Greenland ice cap. It's probably got enough water frozen in to raise global sea levels around 7 metres were it all to melt. So it's on the same sort of scale. That glaciologists have worried about for a very long time. As early as the 1950s, Canadian glaciologists were pointing to its structure, saying that it's vulnerable to melting because the rock it sits on is below sea level. So if the oceans warm and start eating it away from below, we'll get more instability and greater rates of melt. That ice sheet's watched by particularly scientists from the British Antarctic Survey. They've discovered recently that the ice streams that run through it, so that bring block ice through that great ice sheet, have sped up recently, and there are signs of instability in it. We've only seen one ice sheet break up in recent times, and that was the Larsen B ice sheet in the Antarctic Peninsula. It was about the size of Luxembourg, about 4,000 square kilometres, about 700 feet thick, and it broke up in 3 weeks in the summer of 2002. We know from looking at the sediments under it, it had been stable for 12,000 years before that, and no one anticipated its breakup. What had happened was the Weddell deep waters, which flow around it in the ocean, had been slowly eating it away from underneath. They'd been melting at the top. Crevices had occurred, and it just collapsed in one almighty boom over those 3 weeks. The concern is we'll see that sort of instability in places like the West Antarctic ice sheet, and if we do, we'll see relatively rapid rise level. The third and really surprising area that I think the IPCC hasn't given due emphasis to is the increasing difficulty human beings are having accessing water all around the planet. And I'll just talk briefly about my own country of Australia, where over the last 8 years we've had somewhat below average rainfalls, but dramatic problems with accessing water for our cities. There's not a city in Australia now, except perhaps Darwin, that doesn't have water restrictions and very great difficulties in terms of accessing water. One of our larger cities, Brisbane, has had to curtail electricity generation because we don't have water to cool the coal-fired power plants. And the dams in that city are down to 20%. I was just reading about the water supply for Western Victoria, which is in southern Australia. The water supply there is down to 4% in the dams, so drastic shortages. And this is a global problem. We know this because of a very unusual discovery made by atmospheric scientists. One of the greenhouse gases is called methane, and methane is what is in cows' farts and all sorts of swamp gas and all sorts of other things, you know. And it had been increasing rapidly up until 1999 because the tundra's melting and methane's coming out of the tundra. China's digging up more coal, which is rich in methane. There's more natural gas being used, some of which leaks. All of those factors were leading to a very large increase in methane. And then in 1999, the increase in atmospheric methane suddenly stopped. And for the last 7 years, there's been virtually no increase. And that I read that in 2005, shook my head and thought, I have no idea what to make of this. A study published just a couple of months ago solved the mystery. What's happened is that the natural sources of methane around our planet, the lakes, the swamps, the river deltas, have been drying out at tropical and subtropical latitudes. And that is the scale of that drying must be prodigious to offset those new sources. And I think what's happening is this. When just going back to the Australian example, we've seen a decline in rainfall across southern and eastern Australia caused by climate change on the order of 10 or 15% over 50 years, which is not very much. But what's happening now is that lesser amount of rain, as it falls on soils that are warmer, plants that are more stressed for water, less of it's reaching our rivers. It's all either evaporating or transpiring through plants. So 10% decline in rainfall equates over much of Australia to a 60 or 70% decline in stream flow. And you need water to get into your dams to be useful to people. So that's what's happening. It's not necessarily that the rain is falling, is decreasing so dramatically, or there is an element of that. It's that evapotranspiration, I think, has been very gravely underestimated as a factor in a warming world, as the soils warm and the trees get more stressed. All of this, of course, has been caused by 380 parts per million CO2 and the methane and other bits which are minor elements, less than 20% as a whole. And that 380 parts per million, you remember 100 parts per million of that is put up there since the Industrial Revolution, really represents the cost of our industrialisation as the Western world. That's what it cost the atmosphere for us to become rich, successful and industrialised. I'd like to just paint a worst case scenario based on these trends for you, not to scare you, but to let you know how I think things might unfold if we don't actually deal with this problem fairly promptly. You can imagine a world where water is in ever greater demand. Northern China is already on the edge of a severe water problem. Much of Australia is. A good old friend of mine in Queensland said to me, whiskey's made for drinking, water's made for fighting over. And that's very true. People will fight for their water. And you can imagine a world where that's happening, where sea levels are rising, and if they rise substantially, causing a lot of infrastructure damage to our coastal infrastructure, perhaps whole cities like Amsterdam being under threat. We can imagine nations of the world spending trillions of dollars to secure that coastal infrastructure. And if they continue to rise, the waters continue to rise, we can imagine interruption to our port facilities and curtailment of our international sea trade. And of course, international sea trade is what knits us together as a global civilization. Without that sea trade, our global civilization simply wouldn't exist. And in addition to that, hundreds of millions of refugees, particularly in places like East Asia, where there are lots of people living very close to areas that are vulnerable to inundation. Europe thinks it's got problems today with, a few tens or hundreds of thousands of African immigrants, illegal immigrants. And you people think you've got problems with a few million Mexican immigrants coming into the country. Some of you do anyway, I know all of you don't. But imagine what it'll be like when it's hundreds of millions of people looking for new homes. We all know that us humans have a dark side. You'd be foolish to deny it. And that as we get stressed, more impoverished and more threatened, that dark side tends to come out. And this world of ours is absolutely awash with the most vicious weapons that have ever been devised. And I can see those stresses just leading to a world that's more stressed, more inwards looking, more xenophobic. Perhaps some of the things we saw in this country after September the 11th, but magnified on a much larger scale. And when that happens, we need to cooperate as a species, and that is the only thing that will save us from these changes. It's the only thing that will allow us to regulate our atmosphere to the benefit of all. So I can see a new dark age developing, one in which those terrible weapons are out there and our children and grandchildren will have a much diminished quality of life.